All right, folks. Today we are talking evolution. This is a controversial subject in some circles, but in some circles it definitely is not controversial at all. This is a featured article, so it's a AAA rated, the best of the best Wikipedia. Okay, let's dig in, shall we? Evolution is the change in the heritable characteristics of biological populations over successive generations. Heritable and characteristics are both words that have their own links and Wikipedia pages. It occurs when evolutionary processes such as natural selection and genetic drift act on genetic variations, resulting in certain characteristics becoming more or less common within a population over successive generations. Okay. Natural selection and genetic drift. The process of evolution has given rise to biodiversity. Look at all those different mushrooms. At every level of biological organization. Let's have a look at the pic. Darwin's 1837 sketch, a first diagram of the evolutionary tree from his first notebook on transmutation of species. Unbelievable. I wonder if he was building on the shoulders of better scientists before him and just kind of put the last piece of the puzzle together, or did a lot of legwork and really just moved the bar forward tremendously with this innovative idea. I don't know. But this right here is probably the genetic tree of how species evolve and change. Let's keep reading. The scientific theory of evolution by natural selection was conceived independently by two British naturalists. Interesting. Independently. So we only hear about Charles Darwin, but there's another fellow, Alfred Russel Wallace. Consider yourself added to my reading list. Alfred Wallace. In the middle of the 19th century. So that's like 1850s. If you're watching my U.S. presidents episodes, then that's like while the U.S. is in its kind of early infancy, these folks are inventing the theories of natural selection. So while America is literally fighting Native Americans and, running very profitable plantations and electing presidents and so on, these fellows in Britain are basically unraveling what's going on here in terms of the biological processes. The theory, so in the mid-19th century, as explanations for why organisms are adapted to their physical and biological environments, the theory was first set out in detail in Darwin's book on the origin of species. Evolution by natural selection is established by observable facts about living organisms. 1. More offspring are often produced than can possibly survive, and 2. Traits vary among individuals with respect to their morphology, physiology, and behavior, and 3. Different traits confer... there's a lot here. 3 different traits confer different rates of survival and reproduction, something called differential fitness, and 4 traits can be passed on from generation to generation, heritability of fitness. Got a lot to unpack there. Again, a lot of links here. Morphology, physiology, fitness, heritability. In successive generations, members of a population are therefore more likely to be replaced by the offspring of parents with favorable characteristics for that environment. Okay. In the early 20th century, competing ideas of evolution were refuted, and evolution was combined with Mendelian inheritance. That's a big one. And population genetics to give rise to modern evolutionary theory. So in the 20th, it was combined with Mendelian inheritance. What is that? I don't know right now. Will we add it? Let's add it to the... I feel like I already added this, but never be better safe than sorry. In this synthesis, the basis for hereditary is in DNA molecules that pass information from generation to generation. The processes that change DNA in a population include natural selection, genetic drift, mutation, and gene flow. All life on Earth, including humanity, share a last, universal, common ancestor, Luca, which lived approximately 3.5 to 3.8 billion years ago. I reckon that's the first sign of life. The fossil record includes a progression from early biogenetic graphite. What? Biogenic graphite? What the hell does that mean? To microbial matte fossils? To fossilized multicellular organisms. Existing patterns of biodiversity have been shaped by repeated formations of new species, speciation, changes within species, anagenesis, and loss of species extinction throughout the evolutionary history of life on Earth. Morphological and biochemical traits tend to be more similar among species and share more recent a more recent common ancestor, which historically was used to reconstruct phylogenetic trees, although direct comparison of genetic sequences is more common method today. Evolutionary biologists have continued to study various aspects of evolution by forming and testing hypotheses, as well as constructing theories based on evidence from the field or laboratory and on data generated by the methods of mathematical and theoretical biology. Their discoveries have influenced not just the development of biology, but also other fields including agriculture, medicine, and computer science. Wow, a lot to unpack here, lots of cool pictures. Definitely not really getting everything, of course, because you need to at least understand every link. These are morphogs in the height of mating season. Anyways, a lot to unpack here. Homologenous bones in the limbs of tetrapods. Yeah, not even scratching the surface in this article. Super long, super detailed. Malthus. Okay. Let's call it quits here. But again, featured article, lot to unpack, recommended